Hi, my name is Julian Kuzno, and today I'm going to tell you a bit about the evolution of mechanical engineering in the automotive industry over the last century. Car technology has come a long way in the past 100 years, from early advances such as self-starting engines to self-driving cars. The field of automotive engineering has definitely embraced the technological advancements of the past century and will continue to do so in the future. So let's start by going over a brief timeline of the major automotive innovations of the past 100 years. In 1912, hand-cranked engines quickly became obsolete when Cadillac introduced the first self-starters and integrated electrical lighting system. This was a major step which kick-started the trend in making vehicles easier for the operator to use. In 1926, an American engineer named Francis Davis patented the first hydraulic-assisted power steering system. However, it wasn't until the 1950s that power steering gained popularity in production vehicles due to the high cost of this system. This greatly reduced the efforts required by users, especially on heavy vehicles. In 1939, Oldsmobile became the first to mass-produce automatic transmissions under the name Hydromatic. The Hydromatic was designed to combine the hydraulic operation of a planetary gearbox with a fluid coupling instead of a friction clutch. This eliminated the need for declutching altogether, making vehicles much easier to use. In 1952, industrial engineering technician John Hetrick was awarded a patent for the airbag. However, due to the lack of interest and concern regarding safety in the 1970s, it really didn't become a standard feature in vehicles until about 1998. This helped drive legislation as well as innovative engineering to make vehicles safer. In 1956, the first steps towards reducing emissions were taken when Eugene Houdry was awarded a patent for a catalytic converter, which is a device that reduces tailpipe emissions into less toxic substances. The Houdry process helped to conserve natural oil by doubling the amount of gasoline produced by other processes and greatly improving the gasoline octane rating. Without this, it wouldn't be possible for us to have the efficient, high-compression engines that we see today. In 1959, Nils Bohlin, a design engineer for Volvo in Sweden, patented the first three-point seatbelt. This revolutionized motor vehicle safety and is still the single most effective traffic safety device in preventing injury and death. In 1969, the General Motors XP883 concept vehicle was the first computer plug-in hybrid. It featured an electric motor with 6 lead-acid batteries and was capable of reaching speeds up to 60 miles per hour in about 28 seconds. In hybrid mode, the electric motor would do all the work up to about 10 miles per hour, at which point the gasoline engine would kick in and do the rest of the work. If you really needed to go, the electric motor and engine could work in tandem, but it was still a very slow vehicle. In 1994, Daimler-Benz unveiled the world's first car powered by Canadian-developed fuel cell technology. Unlike conventional power sources, fuel cell technology is long-lasting, highly efficient, and drastically reduces carbon emissions. The vehicle needed 12 fuel cell stacks to produce 50 kilowatts of power. Since then, over 150 cars have incorporated Canadian-made fuel cell technologies. In 2003, Toyota started selling the Japanese Prius Hybrid, which was the first car with park assistance technology. This fuel-efficient machine featured new car technology that allowed the car to park with minimal to no guidance from the driver. This was a major step towards self-driving vehicles. In 2008, the Tesla Roadster became the first all-electric vehicle in U.S. serial production capable of reaching highway speeds. With a single charge of its lithium-ion battery pack, it was able to go up to 244 miles and go from 0 to 60 in about 3.7 to 3.9 seconds depending on the model. And finally, in 2012, the Nevada Department of Motor Vehicles licensed the first driverless vehicle, a Toyota Prius retrofitted with Google's experimental new car technology. Using a $70,000 laser radar, the car could see and react to pedestrians, road obstacles, traffic signals, and other cars. It could also merge at highway speeds and change lanes, all without driver involvement. As you can see, the field of automotive engineering has come a long way since 1912. The vehicles on the road today are much safer, more comfortable, faster, and easier to operate than the vehicles in the early 1900s. The efficiency of cars has drastically improved as well. Despite all these advances and improvements in automotive engineering, there are still some core themes of the automotive industry that has remained the same over the last century. Certainly the basic function of the combustion engine hasn't changed, nor is the way one operates a vehicle. At the start of the 1900s, Henry Ford's vehicles had transmission, clutches, brakes, headlights, and pretty much everything else that we still see today. The technology has obviously improved, but the basic function of the automobile itself remains largely indistinguishable from 1912. and will probably remain the same unless they start to hover or fly.